Okay, this next video is going to cover problem 9.12 from Gapenski's Healthcare Finance 6th edition. 9.12 asks you to create an amortization table. So I'm going to do a little bit of it by hand, and then I'll switch over to Excel just to because my handwriting is crappy and there's a lot of numbers here, and so it'd just be faster to do it in Excel. Even though I'm not teaching Excel, I'm just gonna, because there's 5 rows, it'll just take some time. Okay, so Epitome Healthcare has just borrowed $1 million on a 5-year annual payment term loan at 15%. The first payment is due 1 year from now. Construct an amortization table for this loan. So I've got a 5-year loan, right, where I'm going to make 5 equal payments. Now, when I take out a loan, what does the bank do? Well, the bank gives me a bunch of money, right? In this case, the bank is giving me 1 million, right? And then I've got to pay them back some fixed amount at the end of each period for the next 5 years, at which point I'll have 0. Well, what does that sound like? That should sound like an ordinary annuity, right? So to calculate, we want to know what the payment is in each of these periods, right? It's going to be an equal payment. If you had a house payment or a car payment, right, the bank has some percentage rate and tells you, based on the principal you're borrowing and the interest rate, this is what your payments are going to be. So it's going to be a 15% interest rate. Going to borrow 1 million, and so this becomes our present value. The 1 million is our present value because that's the amount of money we're getting today, and then these are all our cash flows that we're going to pay out over the course of our loan. So let's look at it from the perspective of using our calculator and our TVM. So n equals 5, I equals 15, PV equals 1 million. So what we want to know is, what is our payment, right, that we will have to pay out in order to pay off this loan. So let's go ahead and fire up the TVM. So first thing, we're going to clear that TVM out. N is 5, I is 15, PV is 1 million. Compute payment is going to be $298,316 roughly per year. So the payment is $298,316. So it'll be 298K, 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 298K. Right? So 5 payments of $298,000. Now, each year that we make this payment, a portion of that payment is interest, and a portion of that payment is payment down on the principal. So how do we calculate this? Well, we set up an amortization table, right? So the easiest way to do that is just to start writing one out. So, so we have year, beginning amount, abbreviate that back, AMT, the payment, which is always the same, the interest portion of the payment, the principal portion of the payment, and then the ending amount due. Right? So in year 1, our beginning amount is $1 million. Our payment is $298,316. Okay, how much interest are we paying in year 1? Well, we borrowed $1 million. Our interest rate is 15%. So our interest that we owe the bank is 15% of $1 million, or the beginning 15% of the beginning amount. So in that case, 15% of $1 million is $150,000. Well, if $150,000 of our $298,316 payment is interest, then whatever is left over is principal. So that's $148,316 on principal. Well, if we paid down $148,316 in principal, that reduces the amount we owe. So I grab our calculator here, and 1 million minus 148,316 gives us a new balance of $851,684. And I'm leaving off the pennies. Right? So then we would roll over to year 2, 851, 684 is our new balance. Our payment is still 298,316. It never changes, right? Going up here, it's always the same. That makes it easier for me. I don't have to write it again. Okay, this time the interest isn't going to be 150,000. It's going to be 15% of 851,684, which I can't do in my head. And that's 127,526. Okay, so we have a payment of 298,316. Of that, 127,526 is interest. So whatever's left over is the principal. So make that negative. Add it to 298,316, and it turns out the principal payment this time is 170,563. Right? So if we've paid down another 170,000, make that negative and add that to our beginning amount, which was 851,684. And we get 681,121 roughly. So at the end of year 2, we have paid down about $320,000 of our $1 million loan. So then we roll over to year 3. Maybe I won't use Excel. We'll see. 681,121, same payment as before. Now the interest portion of our payment is based on the 681, so times 0.15 gives us our interest is 102,168, which means that if we subtract that from our $298,000 payment, 298,316 minus 102,168, then our principal payment this time is 196,148, right? And so we can subtract that from 681,121, and our new ending balance on our mortgage is 484,973. So I want to make a point here. The payment stays constant, right? As we move along, the amount that we're paying in interest reduces, and the portion of the payment that is going to interest falls, and the portion of the payment that's going to principal increases, right? Over time, they kind of switch places. If you've got a 30-year mortgage, for example, if you look at the amortization table, it's just going to break your heart. But early on, you're paying almost all interest and very little principal, and it's not until about halfway through your loan that it flips and you start paying more in terms of principal than interest. So we'll bring that end amount back down to to make it the beginning amount for the next period. Same payment. How much interest are we doing? Well, 484,973 times 0.15 gives us 72,745. So if we subtract that from our 298,316, that tells us that this time we're paying 225,570 in principal. So we can subtract that from our 484,973. Minus 225. Sorry. We have 259. 403 roughly left. Okay. So our beginning balance is 259,403 in our last year. We still make that same 298 payment. How much of that is interest? 38,910. And then how much of that payment is interest, is principal. Well, we'll just subtract that from 298, 316. Sorry, 39, 38, 910 is 259, 406. So our principal payment against our beginning amount of 259, 403, right? We're roughly, so this is some rounding error built in there. We're off by $3, but basically we end paying it off. Okay, so that's a very simple amortization table, but it works the same whether you're doing annual, quarterly, semi-annual, monthly, whatever. It works that same way.